Welcome back to our software design and development unit and what will be the last lesson within this unit. In today's lesson we are going to learn about testing and evaluation. As always, we have some learning intentions. We'll learn how software is tested using 3 categories of input data. We will learn the characteristics of the 3 categories of software error, and we'll learn the 4 criteria that a development team will apply to evaluate the success of a software solution. As always, we always have some success criteria. Today our success criteria will be: I can describe the 3 categories of test data, I can select relevant test data to populate a test table for a given program, I can describe the 3 categories of software error and identify examples in a given program, I can describe the 4 characteristics used to evaluate a software solution, and I can use the 4 criteria to evaluate a software solution. As always, success criteria should be referred to throughout the lesson to benchmark your progress. Before we move into the lesson, here's a small definition for the term syntax. This is a term that we will use throughout the presentation. Syntax is the structure of statements in a computing language. It is basically the rules of a language. The English language has rules such as starting a sentence with a capital letter and ending it with a full stop. Programming languages also have rules that must be followed. After the implementation process, a program must be thoroughly tested to ensure it performs and carries out the tasks it's supposed to carry out without crashing. Through this testing process, the programmer can identify errors to rectify before handing over the code to the end user. This testing is performed by inputting test data into the program and checking the results against expected output. There are 3 specific test data categories that are used to test a program. These are normal, extreme and exceptional test data. A test table will be produced and populated with data from these 3 categories. Normal test data is data that is expected to be accepted and is within the boundaries of the program. Extreme test data again is test data that should be accepted but is right up on the boundaries of what is expected to be accepted by the program. And exceptional test data is test data that is expected not to be accepted and is out with the boundaries. A quick example would be a program that takes in a number between 1 and 10. Normal test data would be 4, 6, 8. These should be accepted. Extreme test data would be 1 and 10, right up on the boundaries of what should be accepted. And exceptional test data would be figures such as 0, -1, 12, or even a piece of text such as a character. As we mentioned, when we are testing code, a test table would be produced. This test table would include input data, expected output and actual output. If the actual output deviates in any way from the expected output, this could be identifying an error. In this example, we have a program here asking the user to input an age. If the age is greater than 19, the output would be adult. If the age is between 12 and is greater than 12, sorry, and less than 20, then the output would be teen. Any other value would produce an output of child. We can see that the structure of a test table. We have 4 different fields: test type, data, expected output, and actual output. For a normal test type, the data would be something like 15, which should be accepted. Our expected output from that would be teen. We put that data into our program and we get out teen. We see that our expected and actual output match. This shows that there isn't any problem here. Extreme data would be 0. It's right on the boundary. Our expected output would be child, and if we put that into the program and our expected output is child, then our expected and actual output match, signifying no issue. A piece of exceptional test data in this case would be -1, because you can't be -1 in age. Our expected output would be an error. If this is accepted, as it is in this example, where it's producing an actual output of child, this means that there is a problem with the code that needs to be looked at and rectified. In the last example, this test data would have produced an error. There are 3 types of errors that you need to be aware of within the National 5 curriculum. These are syntax errors, runtime or execution errors, and logic errors. Let's look at each of these errors in turn. Firstly, looking at syntax errors. A syntax error is when we break the rules of the language. The most common syntax errors are misspelt command words or variable names. In this example, we have a misspelt command word in input box. We have input box rather than input box. Syntax errors are easily detected and easily fixed. Commonly in Visual Basic, these will be underlined in red. In modern IDEs or integrated development environments, such as Visual Studio, we will automatically flag potential syntax errors to the programmer. As I mentioned, this is normally with an underline of red. Our second type of error is an execution or runtime error, and these occur when the program is executed during runtime. These types of errors are likely to cause the program to crash, and common causes of this are the dividing a number by 0 or attempting to access an array element which does not exist. So it's out with the bounds of the array. Here's an example. Our array has 3 elements, an index of 0, 1 and 2. In our example here, we are trying to access index 3 or element 3, which does not exist. This would cause an execution or runtime error. Our last type of error is a logic error. This type of error will normally occur due to an error with the arithmetic or logic in the program. A programmer could have accidentally used the wrong number values, the wrong arithmetic operator, or logical operators. This type of error will not crash the program, but will certainly produce incorrect output. In this example, we have used an incorrect logical operator, or else if age is greater than 12 or age is less than 20. This should be else if age is greater than 12 and age is less than 20. There is a big difference in this complex comparison, as in this case with the example of or, either the first comparison of age is greater than 12 or the second comparison, age is less than 20, need only be true. The correct use of the AND logical operator would mean that both comparators would need to be true before teen is displayed. When we evaluate code, we are looking at certain criteria. We will start to evaluate code when the testing process has been complete, and the success of the program will be evaluated against these 4 pieces of criteria. Is the program fit for purpose? Is it efficient? Is it robust? And is it readable? For a program to be declared as fit for purpose, the completed program must meet all the requirements specified at the start of the project within the requirement specification. If the software does not fulfill any of these requirements, it is not fit for purpose and may be useless to the client or user. We will then look at how efficient our code is. There are a variety of different ways to produce a functional solution to a problem, but some may be more efficient than others. We want our program to make efficient use of system resources. The programmer must aim to produce a solution with the fewest lines of code possible. In this example, we can see that the programmer has declared 3 variables and used 3 lines of code, each of these lines of code doing a similar thing, inputting a score. This is quite inefficient. In our second example, which is far more efficient, we have reduced the number of lines of code by using an array, and we have used a fixed loop to carry out the same instruction a number of times. The programmer can use loops and other constructs to dramatically improve the efficiency of our code. Our programs must be robust. This considers how well a program handles a wide range of inputs, both expected and unexpected. We want our programs to be robust, meaning that they are unlikely to crash. We will use standard algorithms such as input validation to improve robustness. This will ensure that any unexpected inputs are flagged up, and also provides the user with an opportunity to re-enter this information. Using techniques like this, we will vastly reduce the chance of execution or runtime errors. The readability of code is also important. When we talk about the readability of code, we consider how easy it would be for another programmer to read and understand our code. All programmers have different styles, so this can be really helpful. There are 4 things that can be done in order to enhance the readability of our code. The first one is ensure that we use meaningful variable names. This means that we can look at the names and have a good understanding of what will be stored in those variables. Indentation is also good practice. We are very fortunate that Visual Basic indents automatically within our constructs. As you can see in our example code here, in our while loop, the guess equals input box line is indented. Good use of white space. Don't be frightened to put good white space or good space between our constructs and our lines of code. This allows the code to be far more readable. And finally, internal commentary. In this example, we can see the comment lines, which are green. This allows the programmer to provide information about the lines of code and the constructs. It allows the programmer to tell us exactly what is going on with these lines of code and what these lines of code are doing. This can be very useful if another programmer or coder works on this later on. Thank you for listening to this lesson. Please don't forget to go to our faculty YouTube channel at Greif High Business and Computing Science, and don't forget to subscribe.